Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules.
Okay, welcome to Lesson 15, using the quadratic formula. So in Lesson 14, we derived the quadratic formula, and the classwork opening exercise says to solve this equation using the quadratic formula. So here's the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And all we do, this came from ax squared plus bx plus c equals 0, and solving for x by completing the square. That was lesson 14. So we're going to use this quadratic formula to solve this quadratic. It has to equal 0 before we do anything else. And this is a quadratic equal to another quadratic. My leading coefficient on the left is 4. My leading coefficient on the right is 2. If I subtract 4x squared over to here, it'd be 2 minus 4 and give me a negative 2. I do not want a to be negative, so I'm going to move the smaller one over to the other side. So I'm going to subtract 2x squared. Always try to avoid having a negative a. 4x squared minus 2x squared is 2x squared plus 5x plus 3 equals, the 2x squareds cancel, or 2x squared minus 2x squared is 0 minus 3x. To get this over here, I need to add 3x to both sides. And that will give me 2x squared plus 8x plus 3 equals 0. Now, I always tell my students to list your A, your B, and your C. So A in this case is 2. B is the linear coefficient, 8, and C is our constant, 3. Okay, so there's my 2, 8, and 3 that will be substituted into this equation. So now I write x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, simplify. 8 squared is 64, minus 4 times 2 is 8 times 3 is 24, divided by 2 times 2, which is 4. X equals negative 8 plus or minus the square root of 64 minus 24 is 40, all over 4. And now I want to simplify my radical. And I like using factor trees, 2 times 20, 2 times 10, and 2 times 5. There are all the factors of 40. I have a pair of 2's, which makes 4. The square root of 4 is 2, so that can come outside the radical. And these are not pairs, so I have to resort back to what was left over, and that stays under the radical, and divided by 4. Then I always look to reduce. 8, 2, and 4 are all even, therefore are divisible by 2. So negative 8 divided by 2 is negative 4. 2 divided by 2 is 1, so I don't need to write 1 times the square root of 10. It's just the square root of 10. And 4 divided by 2 is 2. So these are the two answers to this quadratic equation. So it's negative 4 plus the square root of 10 over 2, and negative 4 minus the square root of 10 over 2. Okay, and one other thing I want to say about this. This is a correct solution, but you could split this up and say that x equals negative 4. X equals negative 4 over 2 plus or minus the square root of 10 over 2. And that would simplify to negative 2 plus or minus the square root of 10 over 2. Notice this fraction is the 2 is only the denominator of the radical. Over here, the 2 is the denominator of the whole thing. So you can simplify it to this if you wish. These will give you the same answer. Okay, B has c squared minus 14 equals 5c. This isn't equal to 0, so I need to move everything over to one side. So the first step is to subtract 5c from both sides. And when I do that, I get c squared minus 5c minus 14 equals 0. List your A, your B, and your C. A is 1, B is negative 5, watch your signs, and C is negative 14. So then I write my formula. So you should write this and then write the substitution. Negative B is a negative 5. So be careful there. When that's negative, a negative 5 is positive 5. Plus or minus the square root of B squared, negative 5 squared, plus or minus, oops, I'm not plus or minus, minus, I already did the plus or minus outside, minus 4AC, all over 2A. So x equals 5 plus or minus the square root of, now be careful with your negative, this is always going to be positive, negative 5 squared is positive 25. And a negative times a negative is going to make this positive. So 4 times 1 is 4 times 14 is 56. All over 2 times 1, which is simply 2. Alrighty, so x equals 5 plus or minus the square root of 25 plus 56 is 81. All over 2. I love it when there's a perfect square under the radical because then we have integer solutions. So then x equals 5, or maybe rational solutions, and maybe not integers, but 5 plus or minus 9 over 2. So this one I can simplify. 5 plus 9 over 2, or x equals 5 minus 9 over 2. So x equals 14 over 2, or x equals negative 4 over 2. And finally, x equals 7, or x equals negative 2. All right, so when we're doing these, I didn't mention in part A, you should always check your solutions. And I'm going to go back to A now. And our answer was, okay, I had erased it, so I went back and wrote it back in. X equals negative 2 plus or minus the square root of 10 over 2 is what we got for A. Well, how am I going to check that with my calculator? Well, here we go. I open my calculator up, and I'm going to teach you something about this calculator. You can store values for X. Okay? So it's really easy. So all I have to do is plug this in. So I would say negative 2 plus parentheses for that fraction, the square root of 10, get out of the radical, divided by 2. So that's how I enter that in the calculator, and I hit enter. That gave me a decimal approximation. I want to store that number as my x and hit enter. So now if now the calculator save that as my x. So now if I write it in there, so I can say 4x squared, I'm just putting the original in, plus 5x plus 3. It should give me an approximation of what that value is, 1.607. Now if I do the same on the other side, they should be equal, and that's how you check these. So now I will do 2x squared minus 3x and hit enter. And they check. Pretty cool, huh? All right, so I'm not going to do the minus one, but if you need to see that process of storing 4x again in your calculator, just go back in the video and watch it again. All right, so that's that. Okay, so now it says exercises. That means you. So pause the video, see if you can do numbers 1 through 5, and then unpause the video and see if you did them correctly. All right, actually I would suggest you do one at a time. So do number 1, pause the video, do number 1, and then check to see if you did the same thing I did, and if you got the same answer as I did. And remember, use your calculator to check your solutions, and then you won't have to check with me. Okay, so here we go. Already in standard form, ax squared plus bx plus c equals 0. Beautiful. So then all we have to do now is say a equals 1, b equals negative 2, and c equals 1. Write the formula every time. Write this and then substitute. So x equals a negative b, oops, I keep doing that. A negative negative 2 is positive 2. Plus or minus the square root of b squared minus 4ac all over 2a. Oops, what in the world is that? Okay, extend that. Simplify. 2 plus or minus the square root of 4 minus 4 times 1 is 4. 4 minus 4 is 0. All over 2 times 1, which is 2. Nice. Square root of 0 is 0. So x equals 2 plus or minus 0. Well, that's just simply 2 over 2, which equals 1. So x equals 1. Plug it in here. 1 squared is 1 minus 2 times 1, which is 2. 1 minus 2 is negative 1. Negative 1 plus 1 is 0. It checks. There was only one solution here. Does it have something to do with this thing? Maybe. We'll get to that soon. Okay, continuing on to page 2 and our exercises. So pause the video, see if you can do 2, and then check. Here we go. So ax squared, or we're using a variable b here, that doesn't matter. Don't confuse that with your b in the quadratic formula. So here's the quadratic formula. This b is not this variable. Pretend that's x. So this would be b equals, and these were different b's, so don't get confused by that. All right, so here we go. A is my leading coefficient, 3. B is my linear coefficient, 4. C is my constant, 8. All right. X equals negative b plus or minus the square root of b squared. Don't need parentheses, but anyhow. Minus 4 times a times c. All divided by 2a. This gets very routine after a while. If you memorize this thing, solving by the quadratic formula is a piece of cake. Negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 3 is 12, times 8 is 96, all over 6. So x equals negative 4 plus or minus the square root of negative 80 all over 6. So factors of negative 80 are negative 1 and 80. 2, 40. 2, 20. 2, 10. 2, 5. Okay, so I'm taking this a little further here. I have a pair of 2's here, so I know that I can have a 2 out here. And I have another pair of 2's here, so that'd be another 2 out here, or 4. Okay, I'm just trying to explain to you how to simplify a radical. And that would leave 5 inside. But there is something going on with this thing. What in the world is a negative under a radical? Because every time we square something, we get a positive number, so how can that be negative? To be continued in the future. I am not going to discuss what that negative 1 does under the radical yet. So let's just stop with that. X equals negative 4 plus or minus the square root of negative 80 over 6. Okay, or I could just leave that negative 5 in there for now, over 6. Reduce that to 2 over 3, blah, 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 but I'm not going to worry about that at this time. All right, so I just cleaned this up and just put the answer here, but we're leading up to something here, so I'm going to circle that. Okay, so now let's go on to number 3. Okay, so here's 3, and we have an ax squared plus bx plus c equals 0. It's in standard form. My leading coefficient is 2. My linear term or coefficient is 7. And my constant is negative 4. Substitute in the givens, x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplify. Negative 7 plus or minus the square root of 49 minus, negative times negative will give me plus. 4 times 2 is 8 times 4 is 32 all over 4. X equals negative 7 plus or minus the square root of 1181. Beautiful. Okay, whenever I have a perfect square, I'm going to get a rational solution. I'm leading up to something here. All right, simplify. X equals negative 7 plus 9 over 4. Or, I'm just going to split it here. Negative x equals negative 7 minus 9 over 4. Simplify. That'd be 2 over 4. Or x equals negative 16 over 4. So x equals a half, or x equals negative 4. Okay, there's our two solutions. Obviously, you should always substitute them back in and check. How about we do that with a calculator one more time? Okay, so I'm going to clear it. So 1/2, 1 divided by 2 is 1/2. Store x, enter. So it tells me it's 0.5. All right, so anyway, my equation was 2t squared plus 7t minus 4 equals 0. Assume those t's are x's. 2x squared plus 7x minus 4. Now, if we did this right, it should equal 0. Okay, that means it checks. Now I'm going to store x as 4. So I'm going to say negative 4, store x, enter. And I'm going to save time. Now I'm going to go up. So I'm going to hit second entry, and hit enter. See how I did that instead of typing that all back in? And then hit enter again, and I got 0 again. So negative 4 checked as well. All right, that's how you check in your calculator. Okay, here's number 4. Hopefully you've already tried this. So here we go. A, my leading coefficient is 1. My linear term is negative 2. Don't forget that negative sign. And C is negative 1. X equals negative b, which is a negative 2, which is positive 2, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So simplify. X equals 2 plus or minus the square root. Do not ever get a negative here. That's the biggest mistake. Negative 2 squared is positive 4. Negative times a negative is positive. 4 times 1 is 4 times 1 is 4. All over 2. So x equals 2 plus or minus the square root of 8 over 2. The square root of 8 can be simplified. 2 times 4. 4 is 2 times 2. That gives me a pair of 2's and a leftover of 2, which means the pair becomes 1 outside and the leftover stays under, all over 2. So 2 square root 2 is the square root of 8 because 2 times 2 is 4. Going back inside, and 4 times 2 is 8. Now notice these 2's will all cancel. 2 divided by 2 is 1. And 2 divided by 2 is 1, and 1 times the square root of 2 is the square root of 2. So here is our solution. X equals 1 plus or minus the square root of 2. So there is my solution. Okay. Okay, so there's my answer. I circled the radical. There's a reason for that. I'm going to recap at the end of the lesson. Let's move on to number 5. Okay, here it is not in standard form. Be careful, this has to equal 0. So before we start, I need to subtract 3 from both sides. That's a 3. m squared minus negative 4 minus 3 is a negative 7 or minus 7. 3 minus 3 is 0. So here I have an a that equals 1. Be careful here. There is no linear term. There is no m to the first power, so therefore my leading coefficient would be 0, and my constant is negative 7. Be very careful there. M squared minus 7, no linear term in the middle. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals, well, negative 0 is just 0. So plus or minus doesn't matter anymore either, because nothing plus or minus is just that, plus or minus. 0 squared is 0, so we're going to have a square root of 0. Negative times negative is positive. 7 times 4 is 28, times 1 is 28. So this is going to really clean up nicely to 28 over, square root of 28 over 2. All right, so 28 in a factor tree is 2 times 14, which is 2 times 7. Okay, there's a pair of 2's. So this is going to become x equals 2 square root 7 over 2. And the 2's will cancel, so that my answer is x equals the square root of 7. Okay, now there's one thing I should keep on there, plus or minus. Okay, plus or minus, so that my answer is plus or minus the square root of 7. Okay? Okay, so now it's time for me to go back and explain what's going on here. Okay, so problem number 1. Our number under the radical, now let's talk some terminology for a minute. The number under the radical is called a radicand. Okay, but in this case, the b squared minus 4ac is my radicand. Agreed? B squared minus 4ac is called a discriminant. Okay, discriminant, the discriminant. Okay, so the number under the radical, the discriminant is what it's called. That will tell us how many solutions we have. So here we had a square root of 0. So when you have a square root of 0, so now I'm going to recap here. When you have a square root of 0, how many solutions did we get? We had one real solution. Okay, so I'm going to just do a list here. So the square root of 0 yields one real solution. Okay. Here, the square root of negative 80. So if I have a square root of a negative number, any negative number, then it's going to be imaginary. Okay, we call that an imaginary because the square root of negative 1 is the term I. That's the imaginary unit. And when we graph these, something's going to happen. We'll do that on the next page, but I'm just leading up to something here. I just want to explain that we can find out how many solutions and what type of solution we're going to get from an equation from the quadratics radicand. All right, so here we have the square root of 81. That is a perfect square. So when we have a perfect square, under the radical, that is going to give us, okay, so what did this answer become? I didn't write the answer down. It was x equals negative 7 plus 9, which is 2 over 4, which was a half, and x equals negative 7 minus 9, which is negative 16 divided by 4, which was negative 4. Perfect square will yield 2 rational real solutions. Okay, and let me change this to rational. It'll still be real, but more specifically, it'll be a rational number because if there's a denominator, it's going to be rational. So a radicand of 0 will give us one rational solution. A radicand or a discriminant of a negative will give us one imaginary solution, or actually two imaginary solutions, and a perfect square will yield two rational solutions. Okay, so 0, one rational solution, perfect square, two rational solutions, a negative will give us two imaginary solutions. Alrighty, so now looking at this, the square root of 2 is not a perfect square. That'll give us two rational solutions. This gave us a square root of 7. That is two rational solutions. Okay, but the radicand was negative b plus or minus, or not plus or minus, hang on, I'm thinking the whole thing, just want the radicand, b squared minus 4ac, b squared, negative 2 squared minus 4 times a, which is 1, times c, which is negative 4. So b squared, 4, minus 4ac. So that gave us 4 minus, or plus 4, which is 8. So our radicand was 8, and since that's not 0, it would give us two rational solutions, and we got two rational solutions, 1 plus or minus the square root of 2. So two rational solutions, meaning there's a positive or a negative sign in our solution. All right, and in this one, b squared, there is no b, so that'd be 0 squared. So 0 squared, shouldn't have x equals, the discriminant equaled that. Actually, no, not there, not here. That's just the radicand or the discriminant. All right, so b squared minus 4ac is negative when you bring that over, remember? So it's 0 plus 12, or just 12, and that gave us, since it's not a perfect square, it gave us two rational solutions as well. Okay, so this could be perfect square or any number positive. Okay, so perfect square or positive. Okay, so a positive number here will give us two rational solutions. The 0 will give us one rational solution, and a negative will give us two imaginary solutions. Okay, hopefully that's clear to you now. So now we're moving on to the next page. Okay, here is page 3, problem number 6. Now this one, it says, for exercises 6 through 9, determine the number of real solutions for each quadratic equation without solving. Okay, number of real solutions. That means integers, rational, that kind of thing. All right, not imaginary, negative. So we are talking about the discriminant, b squared minus 4ac. Says without solving. So this is all we have to do. So first thing I want to do is put this in standard form. I want to get everything off to the left equal to 0. So I'm going to do this all in one step this time. You just do the opposite sign of everything. I'm going to subtract 8, and I'm going to add 3p. I'm going to subtract 8 on the other side, and I'm going to add 3p. Notice how I'm lining up like terms, and I get p squared. 7p plus 3p is 10p. And 33 minus 8 is 25. So it's plus 25. Let me write this a little neater. So that was 10p plus 25 equals 0. So now I have a equals 1, b equals 10, c equals 25. So I'm going to substitute it into here. So I'm going to write it this time, b squared minus 4ac. Memorize that discriminant. And b is 10 squared minus 4 times a times c. So it's 100 minus 4 times 1 times 25 is 100, and that gives me an answer of 0. So remember, if I go back to the last page, if I have a square root of 0 as my discriminant, it is one real or rational solution. So it says determine the number of real solutions. One real solution. That is the answer to number 1. That's all they're asking. How many real solutions? Okay? Okay, here's number 7. We already have it in standard form. It's equal to 0. List what we have. What is A? A is 7. What is B? B is 2. What is C? C is 5. Write the discriminant so you memorize it. Substitute 2 squared minus 4 times A times C. 2 squared is 4 minus 7 times 5 is 35 times 4 is 140. That is going to give me an answer of negative 136. Going back, when you have a negative, there are no real solutions. It's imaginary, so I would say no real solution. Okay? The number of real solutions, 0 real solutions. All right, this one does not equal 0, so we need to get everything over to the other side. Always look at your A term on both sides. 2 and 1, move the smaller. So I'm going to subtract y squared. I'm going to subtract a 4y, and I'm going to add 3. All those opposites will yield a 0 on this side. If I'm going to subtract a y squared and a 4y and add 3, then I'm going to get 2y squared minus 1y squared is 1y squared, and 10y minus 4y is 6y, and there is no number over here, so it's plus 0. 0 plus 3 is 3. All right, so A equals 1, B equals 6, C equals 3. B squared minus 4AC, and B is 6 minus 4 times A times C. 36 minus 4 times 1 is 4 times 3 is 12. 36 minus 12 is 24. That is a positive number, so it'd be 2 real solutions. Okay, hopefully you've caught on to this and understand it. This is not equal to 0. I need to move the 4z over to the other side. So subtract or add 4z to both sides. And that is going to be 4z squared plus 4z plus 9 equals 0. List your A as 4, your B is also 4, and your C is 9. So B squared minus 4AC, write this every time so you memorize it. B squared, B squared is 4, 4 squared minus 4 times A times C, and we get 16 minus 9 times 4 is 36 times 4, 72, 144, and that'd be 134, 128, negative 128. It's negative, so no real solutions. No real solutions. Can't have a negative under the radical. Okay, now we're going to apply what we know to a graph or graphs. All right, so here are 4 graphs, and number 10 says on the line below, each graph, right here, state whether the discriminant of each quadratic equation is positive, negative, or equal to 0. Then identify which graph matches the discriminants below. All right, so you need to keep in mind what solutions mean. A solution is a root or a zero or an x-intercept. Here is the x-axis. How many times did this graph touch the x-axis? One time. One real solution. When does that happen? When our discriminant is 0. Okay, let me go back to that rule. Oh, it was right there. Square root of 0. And when the discriminant is 0, we have one real or rational solution. And that's what happens in a graph. It's called a double root. And you have one solution right there. In other words, the graph comes up, touches it, so it's a maximum value of the graph, and then it turns and goes back down. One solution when the discriminant is 0. This one here, here's my x-axis. The parabola came down, the minimum is 1, and it turned and went back up. It never touched the x-axis. No solution is when the discriminant is negative. So now you're getting a picture of what happens when you know the discriminant. If it equals 0, it's a parabola that's maximum or minimum is on the x-axis, just touching. And this minimum is here. It never approaches or reaches the x-axis. It turns and goes back up. So it is a parabola that never crosses the x-axis. This one is a parabola that's hitting the x-axis at 2 locations. Okay, so I know the discriminant is positive. When you have a positive discriminant, you get 2 rational or real solutions. And then this one here also is crossing twice. So therefore, it is positive. All right, so the discriminant. Negative 2 squared minus 4 times 1 times 2. So that's 4 minus 8, which would be negative 4. So when I have a negative discriminant, negative gives us no solution. So that is graph 2. Now this is just a matching game. This discriminant, negative 4 squared, here, how about I do these? Negative 2 squared is 4, minus 4 times 1 times 2 is 8. 4 minus 8 is negative 4. Therefore, it's a negative discriminant, graph 2. Negative 4 squared is 16. Minus times a minus is positive, times a minus is minus again. 4 times 1 is 1, times 4 is 16. 16 minus 16 is 0. 0 is this one over here, so that is graph 1. Discriminant C, negative 4 squared is 16. Minus 4 times 1 is 4, times 0 is 0. 16 minus 0 is 16. Okay, I'm going to leave it at that for now, and I'm going to explain in a moment how to determine which is which here, because they're both going to be positive. Negative 8 squared is 16. Negative times a negative is positive, times a negative is negative. 4 times 1 is 4, and 4 times, oh wait, not 16, my fault. Negative 8 squared, I'd multiply by 2, yikes. 64 minus 4 times 1 is 4, 13. 4 times 13 is 52. 64 minus 52 is 12. I had caught my error because I saw that this was going to be negative if this was only 16, and I know we already had the negative over here. So these two are positive, but which one is this? So now we have to remember that when a parabola opens up like so, A is positive. When a parabola opens down, we have a negative A. Well, the discriminant is b squared minus 4ac. So this negative will be the down one, and this positive will be the up one. So this is negative, so that's down, graph 3. This one is positive, that's graph 4. Okay? And that's how you determine if it's opening up or down. Okay, here's page 4. Consider the quadratic function f of x equals x squared minus 2x minus 4. A. Use the quadratic formula to find the x-intercepts of the graph of the function. X-intercepts. That's the same as saying find the solutions or solve. Okay, x-intercepts are solutions, so all we're doing is saying x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All we're doing is the quadratic formula again. A is 1, b is negative 2, and c equals negative 4. So substituting that in, I get x equals a negative negative 2, which is 2, plus or minus the square root of b squared, which is negative 2 squared, minus 4 times a times c, all over 2a. So x equals 2 plus or minus the square root of 4, and that's plus. 4 times 1 is 4 times 4 is 16, all over 2. So my answer is x equals 2 plus or minus the square root of 20 over 2. Simplify the radical. That is 2 times 10, which is 2 times 5. We have a pair of 2's, so I can simplify that out to being 2 plus or minus 2 square root of my leftover 5, all over 2. Well, 2 divided by 2 is 1. Plus or minus 2 divided by 2 is 1. Square root 5 is simply square root 5. So there are my two x-intercepts. So my x-intercepts are at x equals 1 plus the square root of 5 and x equals 1 minus the square root of 5. Okay, now it says to use the x-intercepts to write the quadratic function in factored form. Now remember, if you have a quadratic, and let's just say you have a quadratic and here's negative 2 and here's 2. And it comes down like this and goes back up, like so. Well, then you know that x equals negative 2 and x equals 2. All right, but if you want to set those equal to 0, actually I should have put them side by side, x equals 2, then you would add 2 to this one, and you get x plus 2 equals 0. And you subtract 2 over here, and you get x minus 2 equals 0. So there's your two roots. So then it would be x plus 2, x minus 2. And when you did the quadratic and FOILed, you get x squared plus 4x plus 4. Just as an example, this would not be the graph of this, but I'm just explaining to you what the solutions do and how you get roots from the solutions by simply setting it equal to, or getting it solving for 0, or getting it equal to 0, I should say. All right, so that's what we're going to do in this problem. Okay, so here's our two x-intercepts. So to use the x-intercept to write a quadratic function, you would just simply say, well, if I have x equals 1 plus the square root of 5, and I want this to be 0 over here, then I have to subtract the whole thing. And what I do to one side, I do to the other. So this is going to be x minus the quantity 1 plus the square root of 5. Okay, and then I do the same for the other one. So if I have x, that's pretty pathetic, x, I'll try that again, x equals 1 minus the square root of 5, then I'm going to subtract. I'm going to subtract 1 minus the square root of 5. And you need parentheses here because you're subtracting all of it. Minus 1 minus the square root of 5. So when I do that, I get x minus 1 minus the square root of 5 equals 0. I should have had equals 0 here as well. So now it says use the x-intercepts to write a quadratic function in factored form. So now I'm going to have this as one factor, times the other factor. So there is our answer, quadratic function in factored form. Okay, and then I just always overlook everything here, or look everything over to see if I don't overlook something. Okay, so it says quadratic function in factored form. So this says f of x equals. So if I want this function, I say f of x equals this. Okay, now it says C, show that the function from part B, written in factored form, is equivalent to the original function. So all they're asking us to do is distributive property throughout, or the, if you will, FOIL. So let me just save some time here by moving, oops. Thought I clicked that, it just ignored me. Let's just move this down like this. And I want to do FOIL. So if I multiply the first times the first, I get x squared plus, I'm going to color code it this time, plus outer is this and this. So x times a negative 1. So it's going to be minus instead of a plus here, because that's a negative. So it's going to be minus. And x times this, so it's going to be minus 1 minus the square root of 5 x. Okay, x times that. Okay, and then the inner is going to be minus again. So it's going to be minus instead of plus, because it's a negative times a positive, and we're going to get the same thing. So the inner I will do in purple. It's this times this. So it's negative the quantity 1 plus 5, square root of 5 times x, which will give us minus 1 plus the square root of 5 x. Okay, plus, and then last, let's see, I'll just use black this time. The last is these two. So it's a negative times a negative, so it's positive. And it's 1 plus the square root of 5 times 1 minus the square root of 5. Okay, now I just need to clean this up. So, and it should also say f of x equals, and f of x equals, and we get x squared. All right, so now we have minus 1 minus root 5 times x, and minus 1 times 1 plus root 5 times x. Okay, so now I'm going to distribute. So x times 1 is minus x. X times a negative 5 is minus root 5 x. And then, well, let's see, minus, yeah, that's minus x, and then minus a negative would be plus. All right, so it's minus x times 1, which is x, and a minus is plus root 5 times x. And then we have a minus 1 times x, which is minus x, and a minus times a positive is minus root 5x. Okay, so all I did there was distribute here and here to get this, and I distributed here and here to get this. Do not forget your signs here. And then it's plus, and then this is FOIL. 1 times 1 is 1, minus root 5, plus root 5 cancels, and minus root 5 times root 5 is 5. Okay, so this simplifies to f of x equals x squared minus 2x plus root 5x minus root 5x cancel, and 1 minus 5 is minus 4. And we have x squared minus 2x minus 4. X squared minus 2x minus 4, it checks. Okay, so now we have the extension here. Consider the quadratic equation ax squared plus bx plus c equals 0, just a standard form quadratic. A, write the equation in factored form. A times x minus m times x minus n equals 0, where m and n are the solutions to the equation. Okay, so keep in mind that when we have solutions to an equation in this form, the solutions to the equation are the quadratic formula. So it's x equals negative b plus the square root of b squared minus 4ac all over 2a. And the other the solution would be x equals negative b minus the square root of b squared minus 4ac all over 2a. Those are the two solutions to a quadratic equation. Okay, the quadratic formula gives you the solutions, so the quadratic formula is positive and negative sign here give you the two solutions. So in factored form, so let this be this solution and let this one be this solution, and so now the answer to this problem is we just need this a. So we would say a times negative b plus the square root of b squared minus 4ac all over 2a times this solution, negative b minus the square root of b squared minus 4ac. Oh, that snap. Oh, snap. 4ac all over 2a. All right. Equals 0. Just like right there. And there's the answer to part A. Very simple. Okay, this is a really long lesson, and I apologize for that. Now B says show that the equation from part A is equivalent to the original equation. Wow. All right, so we have to take this original equation. I'm just going to cheat here. Whoops. All right, you all saw that, right? I clicked on that and nothing happened, and it drew a green line. All right, so there, I cheated. Don't you wish you could do that on your paper? So that's the first thing we want to do is write this. But I don't want the equals 0. All right, so what does that equal? That is going to equal a times, and now I need to FOIL this. So it's going to be oh, I forgot something the last time. That's not the answer. It's x minus and x minus. Okay, my fault there. So it's a times x minus. I forgot the x minus, the x in front. Okay, so it's going to be x minus b plus the square root of b squared over 4ac times 2a times x plus, all right, or x minus b squared minus, okay, so I forgot my x in front here. All right, so now we have to FOIL these is what we have to do. So x times x is x. Now I'm going to use green. X squared. All right, x times x is x squared. First times first. Outer would be this times this, which is negative b minus the square root of b squared minus 4ac all over 2a times x minus, because now we're doing, this is the first here, this is the outer, now the inner is x times this, which is negative times a positive, so it's minus, and it's going to be b plus the square root of b squared minus 4ac all over 2a times x. Okay, so this times this is this. This x times this over here, x times a negative b minus, actually this should be plus, and this one should be minus because of the signs when you're multiplying. Not that it matters because you have two different ones, but technically you should do that. Okay, and then last. So it's a negative times a negative, and I need to multiply b times this, so it's this times this, and that is going to give us b times b, which is b squared. And the square root of b squared minus 4ac plus and minus there, so that's going to be minus. And when you multiply a radical times a radical, you get the radicand. So it's just going to be b squared minus 4ac. Okay, that is this piece minus this times this piece. All over 2 times 2, a times a. Okay, close the parentheses. So it's all of this times a. So that is going to equal, this is quite lengthy, a times x squared plus, and what's going to happen here? It's this, these two terms here, all I'm doing is putting these two things in parentheses. So it's b minus the square root of b squared minus 4ac all over 2a plus b plus the square root of b squared minus 4ac all over 2a close the parentheses times x Alright, so what we're doing here is, let's just recap here, x squared came down, and this and this, okay, we just changed the signs here to plus. It's both of them, and we just, since they're both being multiplied by x, I just factored out the x and put it outside this parentheses is all we did. And I just rearranged it so the minus is minus and the plus. Actually, this should be a plus right here. That's where I made the mistake earlier. Okay, so that's plus and that's minus. Yes, plus and minus, and then it switches. I just put the negative one first and the positive one second, and then put the x here. It doesn't matter because this minus, that's all. And then it's going to be plus, and then what happens here? We have a b squared minus 4ac all over 4a squared, and let me change colors to show this. B squared minus b squared, b squared minus b squared is 0. So I have a minus 4 over 4, so that's going to cancel the 4's. And that minus and negative is plus, so 4 over 4 is 1. That goes away. So now I have a, that cancels with one of the a's down below, and that cleaned up to just c over a. So now I'm going to simplify this a little further. So it's going to equal a, parentheses, x squared, plus b is 2b. A negative radical plus a radical cancels, and so that's 2b over a 2a times x plus my c over a. Okay, and then when I multiply all that by a, then I get a times x squared, which is ax squared. This A cancels with this A, leaving 2 over 2, which is 1, or simply B. Everybody see that? 2 over 2 is 1, and A cancels this A, leaving B times X, or BX. And then that A cancels with that A, leaving C. So then we get AX squared plus BX plus C. Woo! That was brutal. Okay, page 5 is the lesson summary and problem set. So that is the end of lesson 15. Review the lesson summary and go do your problem set.